Hi everyone. We only have 15 minutes of time at this free screencasting thing, so here's part two. Um, okay, we might skip that one because it's not very interesting. So chapter 5 was where it got a little bit cerebral, a little bit difficult. Also, I found this sign once and went, oh my gosh, I have to use it in a class. So here we are, thank you. There were a few key points here that we need to take away from week 5. And that was this concept of sampling error, which is different to sampling distributions. We talked about sampling distributions for the mean and for the proportion. Now, every statistic has a sampling distribution, but there are only a very few special ones whose sampling distributions we can describe easily. I've been doing this for since the dawn of time, and I cannot tell you what the sampling distribution for the median is. I can't tell you what the sampling distribution for the kurtosis is, or skewness. I could probably work that one out, but it's not particularly useful. So only special statistics have easily described sampling distributions. There are a lot of them, but there are special ones, and generally there's some sort of variation on the mean or using those. Ori, I'm trying to do a class right now. Out. And that would be my kid looking to plug her iPod in. Sorry. Now, my pro tip, if you're going to learn something that's going to get you that HG, and obviously I don't know what's going on the final exam, but what a lot of people overlook in this week's material will be the sampling distribution of the proportion. Okay, so make sure you know that. Now, the central limit theorem was something we discussed a lot this week, and that is different to the sampling distribution of the mean, though it is related. A lot of people find that very confusing and overwhelming because we keep talking about, well, if we took 100 samples or if we took 1,000 samples, then this would happen, when in reality we only ever take one sample. So it can seem like a very, very cerebral and unintuitive concept. So step 1, don't panic. Step 2, if you are going to take one thing away from this week's material, I want you to take away this, and that is the fact that this week's material, the central limit theorem and so on, is the toolbox. It's the way we build the bridge from descriptive statistics, from describing the sample that's in front of us, to inferring information about a population, and that's what statistics is all about. Okay? So this is the bridge. That's what we're getting out of this. Now, because this is like my favourite week ever, I had a lot of materials up on the discussion board to help you out here. We had some videos. We had the sampling mean distribution, so you can see how that would work as the sampling size increases. I did some GIFs just because I really wanted to. And we also had a discussion board activity video where I showed you step by step how I would answer a question in the exam. We also had some online demonstrations. I linked you to a website that shows you in a visual way what the central limit theorem is doing. We also put up printable notes, including all chapters, and a CLT infographic. So there's a few different things up there. Now, here's an example of an exam question in this particular area. The time for a standard service on a particular washing machine follows a normal distribution with a mean of 40 minutes and a standard deviation of 3 minutes. If X bar is the mean of a random sample of 36 service times, what is the expected value of X? And that would be 40 because we've been told the mean is 40 minutes. What is sigma X? Now, this one threw me the first time because that answer that's been given there is incorrect. Sigma X, we've been told, is 3 minutes. That's a trick question. Even the person that did the solution didn't notice. This solution that's given here is for sigma X bar. Okay, so bear that in mind. Part 3, sketch on the axis below and name the graph of the distribution of X. Show your scale and explain why it has the name you have stated. This is the sampling distribution of the sample means and shows the range of possible sample means when samples of size 36 are drawn from a population with a mean 40 and a standard deviation of 3 minutes. Now, the critical part here is that it's a bell-shaped curve. It's fairly tight, around 40. We can see that the middle is in 40 there. And do you remember the 95% rule? What was it, the 1.645 rule? Use that to work out how this axis should go down here. Okay, so we know that the sigma X bar is going to be 0.5 of a minute, and we know that about 95% of the sample mean distribution should be within 2 standard deviations of that mean. And that's hence why we get 39 and 41 on either side there. Okay, so chapter 6. Hey, I could even do this now. All right, so chapter 6. This is the week where we got really very practical. We went from that very theoretical concepts to actually doing something very practical. So we've described samples, we've talked about why random things behave the way they do, and now we're going to take all this information and we're going to start making inferences about populations. So the critical points here was the difference between point estimates and interval or confidence estimates, okay? A point estimate, so a point estimate for the mean is just x bar. A point estimate for the mean is also 2, but it's not a good estimate. Okay, a confidence or interval estimate is when you've got that plus or minus concept around it. We give a range. We also talked about the t-distribution and when we would use that. And my pro tip for getting a HD or for that, one really tricky question on the exam, if it was coming from this week, and I don't know what's going on your exam, but if the tricky question was coming from this week's material, it would probably be calculating the sample size. That would be the hard question because a lot of people miss that one. Okay, so make sure you know how to do that. We talked about the confidence interval for the mean when sigma is known or n is large, and that's when we use the z-score. We talked about the confidence interval for the mean when sigma is unknown and n is not large. The other thing that a lot of people miss in this week's material is the confidence interval for proportions. So definitely know how to do that. That's my kids yelling in the background. So since doing these slides on Monday or Tuesday, we've added a few things. We've done a couple of videos since then. And we've had a bit of a discussion, particularly we were just talking about those difficult normal probability questions where we got to work back to find the standard deviation. And I put a video up on that. So I'm very sorry that last week's Collaborate session was a technical fail on a number of levels. Hopefully this gives you the rundown of what I wanted to do that night. I will post the recording in any case, but thank you very much. Have a great week off for revision and things, and I'll see you when we get back. If there are any urgent inquiries, please do email me over the break.